Hi guys, my name is Bleep, I am Bleep, and obviously I'm not important. However, today I want to send you a clear message if you're an engineer that works for white goods or air conditioning, refrigeration, electrics, or even if you're a programmer. As you know guys, some of us are programmers, some of us are control analysis engineers, some of us with design programs, and some of us control philosophy. Smart people which understand how a process works, and then we'll write a control philosophy, we'll put it on a URS, and we'll send it to software engineers that will convert our dreams into reality. Now, I choose today to talk about the tumble dryer. Why? Because people say it's just a box, but strangely, I just discovered that many people don't even understand the process of drying up something using multiple methods. One of the most newest tumble dryer on the market is the heat pump tumble dryer, and many technicians get confused. And I looked to YouTube and I found so many technicians explaining in an incorrect way how a heat pump tumble dryer works. They come with the thermometers and with some other things. I'll explain to you a little bit how the process of the tumble dryer it is and where you have to look if the tumble dryer doesn't work. You don't know, but the tumble dryer, let's start with the heat pump itself, because that's why you call it heat pump tumble dryer. You have two heat exchangers, a cooling heat exchanger, and also you have a heating heat exchanger. If you are a refrigeration engineer, you will understand. What do you need these two? I'll explain to you in a minute. You also have a fan. We can put it anywhere. So you have a fan, let's make a scroll fan, which is driven by a motor. Right? There are many types of tumble dryer, but let's choose this version of it. And on this side of the motor, to the rear side, you have a belt which spins the cylinder where you're closing and drying in the same time with the fan. So you also have an electronic control. It's a printed circuit board which have a lot of probes fitted into some area, and these probes collect the data, send it to that printed circuit board, and the circuit board's processor take action and instruct different parts of these tumble dryers to run. But let's not go complicated about this. So you see, I have other videos and I show how this works, but I want you to understand one thing, because I saw some mistakes on YouTube and they're quite painful and will put technician on wrong pathway. Why do you use two heat exchanger? If you're a refrigeration engineer, you know when you circulate the air, so let's say the circulated air goes through the tumble dryer to that cylinder via the fan, and it passes by through this very cold heat exchanger. This cold heat exchanger allows the water, the moisture from your clothing to condense, and the water will fall into the drip tray. Then the air here, it is cool and dry because it just passed by this cooling heat exchanger, and it is reheated by the heating heat exchanger. In our case, this is just a condenser. We have to know a bit of refrigeration and air conditioning to understand how this process works, because this system uses refrigerant. It's just like your fridge. It removes the heat from your fridge and dumps it out on your kitchen. So now, this air which passes by the heating heat exchanger, it is hot and dry. Yeah, it's hot and dry. And it goes inside this cylinder or interact with your clothing, sucking the moisture because the air it is hot and dry, and continue his journey outside. When he goes outside, it is warm and wet, and he goes back into this cold heat exchanger where you will retain the moisture. You know, if you take a bottle from the fridge, it will sweat. That happened here. So the air which passes by drop the moisture, and this is the cycle. So I hope you understood. This is the cycle. Now I'll explain to you how the tumble dryer, the smart sensor, know when the clothing are dry. So let's go to the next page. So guys, you have the printed circuit board. You call it controller, whatever you want to call it. This is your printed circuit board. Printed circuit board have a software written on it, and you respect the protocol. This printed circuit board have, let's say, 2 wires, and inside the cylinder where you dry your clothing, not in the cylinder, you have a space onto the fascia of the tumble dryer. Let's say this is the fascia of the tumble dryer where you put the clothing inside. You have 2 pieces of metal very neatly put it into the plastic of this fascia. So what happened? The printed circuit board sent information to this wire, through this wire, into this plate. And you know, the electricity passes by through the water, not through the pure water, through the water, because water is not pure. If you have pure water, the electricity is not passing by. So when the clothing are wet, this signal passes by through the clothing, because they're wet, when they just spin inside this, when the cylinder just turn them, and is returning into the printed circuit board, and the printed circuit board know your clothing is still wet. That's why sometimes you have problems. If you have wet clothing surrounded by the dry clothing, if you put, as an example, a big bed sheet, or if you put something very big and inside you have some wet stuff, the machine might stop and you say, well, this machine doesn't work well because my stuff is still wet inside. But honestly, that might not be the reason, because if these blades are not touched by wet cloth, you will not send back the signal to the PC board, and then the machine will think your system is dried, and it will stop. So I hope you understand. So it's a feedback, like you chuck a ball into a wall and it come back to you. So this is the effect, and that's why you know the wall is there. That's in our clothing. We send an electrical system, and you have these 2 blades. So the clothing is spinning, you touch both blades, and the signal come back into the PLC. If the clothing are dry, the electricity is not going through the clothing, because the clothing are dry, and then your machine will know that the clothing are dry, and you will stop. That's the 6th sense sensor, as they call it. Now, you understood the refrigeration process, you understood the mystery of 6th sense. You have to be very careful when you open the door of your clothing, of your tumble dryer. You stick the hand inside and you'll see 2 pieces of metal, very neat, because they don't have to destroy your clothing. They're very neat into the plastic. So the clothing, when they spin, they touch both of them. And if they're wet, the electricity pass by. So the signal will return into the PC board, and PC board say, oh, they're still wet. So they continue the cycle. Now, as you know, probably you have to be a refrigeration engineer to understand this. So you have the cooling Also you have the it's wrong. I should do better so you understand better. So this is the cooling heat exchanger. We call it the evaporator. This is the condenser. And this is the compressor. So how this mystery goes, how this system goes. So the compressor pushes the refrigerant, a very hot refrigerant, in the condenser, and the condenser pushes the warm and liquefied refrigerant into the capillary tube, because they're not using TX valves, and then refrigerant reaches the evaporator. In the evaporator the pressure is low, so the refrigerant expands, absorbing the heat, and then from the evaporator the refrigerant is returning into the compressor. So you have this cycle all the time. So a very hot refrigerant, like let's make it hot so you see it better. This is the hot refrigerant. This is a warm refrigerant because it's cooled by the condenser. And this is a very cold area, is the evaporator. But you can't have this cycle running like that, because the evaporator will ice up and the liquid will return in the compressor to blow up, and it won't make sense to run a system like that. It doesn't mean nothing. So we have a fan. We have a fan and a motor. Now, this fan circulates the air. See, become messy. And this is the cylinder where your clothing are drying. And this fan sometimes have that belt which turn the cylinder. Probably the cylinder is bigger than this. It's not a perfect design, but I hope you'll understand. So let's say the cylinder is still here. And this is your shaft of the motor, and then you have a belt. Because sometimes one motor have double function. It turn the belt, which turn the cylinder, which drying your clothing, and in the same time, it's turn the fan. Also, you have filters. If you look at my other videos, you'll understand what the filters are, because you don't want to block the evaporator. It's very thin. It's got fins like the car. You have in front of your car the radiators, which cools the water, which cools the engine. Let's not talk about that one right now. So the air comes very, let's say when you start the cycle, the air circulates, then the printed circuit board will enable the compressor. When the compressor is on, the refrigerant starts to circulate through the system. And the evaporator gets very cold, and the condenser gets hot. So the air circulates, and then the air starts to cool down in this section here. This is cold and dry, because you will allow the moisture to condense on this section, and it will be collected on a drain tray below to be removed by the water pump. I have a video explains it. And then the air, it's dry and cold, but then it's reheated and it's dry and warm. It's like a sponge, dry, and it sucks the moisture from your clothing, and then it comes back wet and warm. So this is hot and dry, and it comes out wet and warm because it's exchanged heat with your clothing. And then it goes through the filter. I didn't forget, but so let's say you have a filter here and another filter in front of the evaporator. Passes by through this filter, sometimes you have to clean it. And again, it drops the water, and it drops the moisture, and it's cold and dry. And then it's warm, it's hot, and cold and dry, then it's hot and dry. And here becomes warm, yeah? and wet.